there we go, okay. So what are the potential problems right now with the way we introduce staplers? We introduce them blindly. The goal here is video-guided stapling allows you to get to the target under direct vision and prevent catastrophic episodes such as creating a colovaginal anastomosis. It allows you to test the cuff before firing the stapler, and it makes sure that you've cleared the rectum from other pathology. That's the rationale behind it. How do we introduce anything into the lumen right now? It's under direct vision. Even if you're using a small pediatric colonoscope, you don't do it blindly. You don't close your eyes and insert that. You do it under direct vision with the insufflated rectum. How are we putting in staplers through the rectum? Blindly, in a desufflated rectum where you don't know what you're doing, you can't see what you're doing. Video-guided stapling looks to answer this problem. Why can't we see what we're doing as we introduce the arm of the stapler? And basically, video-guided stapling allows you to use this arm of the stapler as an access channel. Here's how it works. You take an already existing scope and you marry it to the arm of the stapler to allow you to visualize every step of the anastomosis. What's the analog for this? Video laryngoscopy. We know that for complicated airways, this is already done. It's the analog of this. This is video-guided stapling. Imagine a scope within the EEA stapler to allow you to visualize what you're doing and seeing everything precisely. You can also advance this through the anvil so that you can navigate and see beyond the anastomosis once it's constructed. Again, the idea, let's turn this with very low cost, turn the arm of the stapler into an access channel. I can see, I can deliver a scope, and I can insufflate. So that I'm not seeing anything, I can illuminate rather than having a dark, desufflated, collapsed lumen, I can see everything. And the idea, of course, is that I want to see my very steps when it comes to the anastomosis. When I insert to the cuff, I can do the air leak test for the cuff to make sure there's no leak before firing the stapler. And then when we have the rendezvous with the anvil, I can see every step so that my anastomosis can be very precisely done. This is the endoscopic view from a stapler, the anvil going through in this model. The two ends are mated. The anvil is mated to the arm. And now you will see what it looks like to view from inside and watch at the moment of stapling. So you see very precisely, in great detail, every piece, every portion of that anastomosis to make sure it's intact. This is just another example. As you fire, you can see simultaneously your anastomosis being constructed, as shown here. What are the potential things that you can do beyond this? You can introduce effector arms, because the scopes already come with all this technology. We don't have to build it. It's already there. And I can look beyond the anvil, and I can do things with this effector arm that I can introduce through a scope, through a stapler. What can I do? I can manipulate the anastomosis, for example. Here in this video, you can see that through the scope, introduced through the access channel, I can grab things. Maybe I can control bleeding. I can put a clip on. Here's an example of that effector arm going to the staple line after the construction of the anastomosis, and you can see that you can grab something for hemostasis, potentially put a clip on, and other effector arm-based manipulations. There are other things that you can do, such as retroflexion, to examine the opposite or flip side of your anastomosis. And I've tested this in a calf colon model, and you can see that after anastomosis, your view is just like you would see with flexible endoscopy. You can see that perfectly. So it's like doing a flexible endoscopy at the same time. So why does this make sense? Because we don't have to throw in lots of capital to develop a scope that's built into a super expensive stapler. We can just borrow existing technology and marry it to existing stapling devices. And these staplers don't have to be modified such that you change or interfere with the stapling mechanism itself. So what's the IP? There's a patent filed in December. It's a patent pending status as a utility patent applicable to United States. It's very broadly written so that it applies to any video device used with any type of endoluminal stapler. The ask is for $30K to work out a prototype and to perform further animal and cadaveric testing over a 12-month period. And I'm looking for a partnership with a vendor to develop this further and obtain 510K approval. And in exchange, I'm looking for a royalty agreement with an existing vendor. Thanks.